So we're computing the mean, variance, and standard deviation for a discrete probability distribution. This is page 159 out of our text, and it's the first example that we see this. So here are the formulas. So the mean, or the expected value, is the sum of, that's how sigma is read, the sum of x times p of x. So we're going to multiply x times p of x, and then we're going to add those up. That'll give us the mean. The variance is a little bit more complicated. We have to subtract the mean that we just computed from the previous step from x, then square that, then multiply that by the probability of that discrete quantity, and then the standard deviation is just the square root of that variance. So we're given a discrete probability distribution from the US Census. It tells us the probability of each household size. So in this example, x is the number of people in the household, and we need to translate the probabilities into decimals. So here are those x's and p of x's, the probabilities made into decimals, and then multiplied across. Now to find mu, we simply add up that bottom row. So we take all those values and add it up. That gives us our mean, 2.525 people per household in the United States, approximately in 2010. Now, the variance is a little bit more difficult. The first two rows of the table are exactly what we had before. X is the number of people in a household. P of x is the probability of that. And then we subtract mu, that is the probability from the mean of this probability distribution, from x. We say from, and so we read it in the opposite direction. That means x. So in this first example, that means 1 minus mu. So that mu, remember, up here of 2.525 people. And when we do that subtraction, we get x minus mu, and we continue doing that. So right the way across, we take, in the next case, 2, and we subtract 2.525, and we get the next difference, negative 0.525. We continue across doing all of that. Then we take that previous row, that is the x minus mu's, and we square them. So we multiply them by themselves, and then we multiply that, and this is the first time this table uses the probability. We multiply that next row by p of x, then we add up all of those in the bottom row. That's what that sigma means, to add up all of these in the bottom row, and we get the variance. To find the standard deviation, we take the square root. I've also made this into a spreadsheet, and I'll be happy to send this out to you. So you can copy and paste the values in for those probabilities of each of these discrete values. And then here's that product, so you can see B1 is being multiplied by B2. Here's the mean, that's just the sum of the 3 row from B3 to H3. And then I copied and pasted for lines 8 and 9, those same values. I then did the subtraction, so when we look at this, it's B8, so that's x, minus that mean. The dollar signs just fix that value at the location B5, and that's the mean, 2.525. And I continued across doing that. And the next row, I squared the value above it. So B11 is just B10 squared, and similarly across the board here. So for example, F11 is F10 squared. And then I multiplied that previous row, so in this case that would be B11. I multiplied B11 by B9. Remember, B9 is where we're putting our probabilities, and continued across doing that. Then when I added up all of the values in the 12 rows, so that looks like that's B12 through H12, that gave me the variance. And then I took the standard deviation, that is raising it to the 1/2 power, to get the standard deviation. So I hope that helps. It looks like there's a glitch in one of Kate's values right there. It looks like she has in the book something different. So I'm getting 0.105. It looks like she has 0.098 in the book. I hope that helps. Feel free to ask any follow-up questions, and I'll post this soon.